Hello and welcome to the last problem that you're going to work out with me. You have one more with Miss Morgan after this. Um, so this is the last problem you're going to work out with me all year long. It's been a good year, 1371 and 1372, a strange year, challenging year, and you guys are almost done. I'm proud of all of you. You've worked hard to stick it out through some very challenging times. I've enjoyed working with you. This is our last problem together, unless you come to my office hours, which I strongly encourage. So in this problem is a polar area problem. We're trying to find the area that lies both within r equals 2 minus cosine theta and within r equals 3 cosine theta. First thing we have to do is try to figure out which curve is which. And I recognize that r equals 3 cosine theta is a circle on the positive x-axis, and I recognize that is the red curve. And that means that the blue curve is the r equals 2 minus cosine theta. Next thing I want to do is identify what region I'm trying to find, and that's this region here. I always ask myself, does it have symmetry? And yes, it does. The top half is exactly equal to the bottom half. So I'm going to focus on the top half. When I want to find its area, I want to highlight the portion of the curve that touches the region in the two different colors, and then draw lines to the origin in those two colors. Do this with both regions. If you've done this enough, you don't have to do it all. You can do it in your head, but if it's been a while, it's worth doing, drawing and shading the regions to help you keep things straight. At this point, I want to start expressing my area in terms of these two regions, because in polar curves, we can't find the area using two curves like we did with functions, y equals f of x and g of x. We just said, oh, it's the inner area between f of x and g of x is f of x minus g of x, and we just did it all together. But now, polar area, you find the area between a curve and the pole, and you can really only handle one curve at a time. And so what we do is we say, okay, well, let's talk about the areas we can find. I can find this blue area. And I can find this red area. Those are the two areas I can find. How does the area I want relate to these two? And I say, okay, well, they don't overlap. And so I want to add them together. And then because of the symmetry, I need to multiply it all by 2. Getting the next line started is pretty straightforward. It's just like building a Mad Lib to fill in later. We know polar area is 1/2 r squared d theta. And so this becomes 2 times 1/2 the integral of something squared d theta plus 1/2 times the integral of something squared d theta. And all we have to do now is figure out which curve is which and what the appropriate bounds are. Now, we already decided which curve was which. The blue curve was 2 minus cosine theta. And the red curve was 3 cosine theta. To work out our bounds, we go back to our little drawings and we say, okay, we know polar curves always go counterclockwise. And so it's starting here, ending here. It's starting, I look at it and say, oh, it looks like angle 0, but I'm not sure yet. So I'm just going to call it the horizontal angle. It starts at horizontal. That could be 0, pi, 2 pi, 3 pi, and it ends at the intersection. And the red curve, well, again, we go counterclockwise. And so this red curve starts at the intersection and ends at the origin. And so now I want to first find the intersection. intersection, I set the two curves equal to each other. So I get 2 minus cosine theta equals 3 cosine theta. 2 equals 4 cosine theta. 1/2 equals cosine theta. Cosine theta equals 1/2 has several answers, including minus pi thirds, 5 pi thirds, etc. But I want the one that's in the first quadrant, so I'm going to pick pi thirds. And so that tells me my first integral is going to end at pi thirds, and my second integral is going to start at pi thirds. At this point, I know the horizontal angle I want, right? I have my horizontal angles are minus pi, 0, pi, 2 pi, etc. And I want the one that comes just before pi thirds. And so that means I'm going to pick 0. The other thing I need to know is when the other curve is at the origin. That will tell me when the red curve should end. And so I say, okay, origin. I know our polar curve is at the origin when r equals 0. And that r is 3 cosine theta equals 0. So that's cosine theta equals 0, which has a number of answers, including minus pi halves, 3 pi halves. And I'm looking for the one that comes right after pi thirds. Which of these is the next one we hit after pi thirds? That's pi halves, which tells me that this integral should end at pi halves. Those are the problems. Thank you very much.